The journey to calculus, this is part two. Part two, we continue from part one. First thing we're going to look at is the domain. How do you find domain of a given function? So I'm going to write several examples. This first one, this is a polynomial function, or you can be given something like this, a rational function, another rational function. We're going to look at these and see how to find the domain for these functions. That's what we're going to see now. We're going to look at domain. If you remember, domain has to deal with the x-axis. Domain has to deal with x-axis. So how do you find domain for such functions? Okay, so it means what are the values you're allowed to substitute into these functions? So the first thing, just keep in mind, when I say y equal this stuff, that means it's f of x, a function in x. So this is a polynomial function. Polynomial functions, their domain is always all real numbers. We write it like this, or you can say all real numbers. And in the interval notation, that would be negative infinity to infinity. That's called interval notation. For the second one, here we are not allowed to divide by zero in mathematics. Anything divided by zero is undefined. So this means if I take the denominator, this denominator cannot be 0. So x cannot be 8. So what would be the domain then? Domain is going to be all real numbers except 8, number 8. So you can't have 8 in there. So it's going to go negative infinity to 8, union 8 to infinity. So this means I'm excluding 8 from the domain. I'm excluding 8 from the domain. Next one, x cubed minus 9x. This cannot equal 0. X times x squared minus 9 does not equal 0. X times x minus 3, x plus 3 does not equal 0. So then, how do you finish that up? X cannot be 0. See what I did factoring here. It's important to know factoring. X cannot be 3 and x cannot be negative 3. If you put the word and, that would be the best. So this means domain is all real numbers except 0, 3, and negative 3. If you write interval notation to exclude these values, you always start from the left side, negative infinity. If you're going to put on the number line to see it, it can be negative 3, it can be 0, and it can be 3. So it's negative infinity to negative 3, union, negative 3 to 0, union, 0 to 3, union, 3 to infinity. So that means we are excluding negative 3, 0, and 3 from the domain. Other examples, say x over x squared plus 9 or 49. Look at more examples. Y equals square root of x plus 3. Another one would be x over x minus 2. So what do we do with the first one? Well, you can have everything but any number that would make the denominator 0. Well, this one, notice this cannot be factored. This will never be 0. This is never going to be 0. So the domain is all real numbers. So you can put any number you like there and it would never make the denominator 0. Even if you put negative 7. So when you are squaring negative 7, you're getting 49. So you will not get, you get 49 plus 49, which is 98. It's not 0. For the radical case, if we have a function, radical functions, you need to make sure this quantity under the radical is bigger than or equal to 0 in order for this to be defined over the real numbers. So this means x must be bigger than or equal to negative 3. So the domain is going to be from negative 3 to infinity. That's the domain. For this one, this bigger than or equal to 0. How do we solve inequalities like this? I always use the number line. Number line is the easiest way. What makes this 0? 0 and 2. We may pick x equals, let's say, 3 as a testing value. So if you pick 3, that will make this positive. If you pick x equals 1, that will make it positive over negative. So that's a negative. If you pick x equals negative 1, you're going to get negative over negative, which is positive. So then, when is this going to be positive? Well, I see it here and here. So it's negative infinity to 0, bracket, union, 2 to infinity. At infinity, we always have parentheses. Here, I put a bracket at 0 because it's okay to have a 0. 0 over a number 0. And the square root of 0 is 0. It's okay. But the denominator cannot be 0. That's why I cannot include the 2 in the domain. So I put only a parentheses, not a bracket. So parentheses means you're not including that value. This bracket here at 0, that means you include the 0. And to practice more on these such inequalities, let's say we're asked to solve x minus 3 over x plus 1 less than or equal to 0. So how do we solve such inequality? Well, we put that on the number line because it's already less than or equal to 0. So on the number line, what values goes here? We have a 3 and -1. We pick testing values. If you pick 4, let's say x equals 4 or 5, that's going to give us positive. If you pick 0, that's going to give us negative. If you pick -2, that's going to give us positive. So then what would be not the domain here, but the solution to this inequality? It says when is it less than or equal to 0? It's in between here. So that's -1 to 3. Now -1 is a parentheses, but the 3 bracket. Why bracket? Because it says or equal. Or equal. Another example, say x squared over x squared minus 5x minus 6. And then let's say it's less than 0. Now we're going to look at another one, x plus 3 over x squared plus 4 bigger than or equal to 0. We're going to look at these two examples. So first, nothing can be done on the top, but the denominator I can factor is x minus 3, x minus 2. And now what goes on the number line? 0 goes in here, 2 goes, and 3. So what do we have here? When x is 4 as a testing point, that will make it positive. X is 2.5, let's say. Positive, negative, positive, so that's a negative. X equals 1. Negative, negative, that's going to be positive. X equals -1. Negative, negative, positive. So when is it negative? That's what the question is saying. Well, it's from 2 to 3. And notice both must be parentheses because the inequality given is only less, not or equal. So that would be the solution. How about the next one? Well, next one, we cannot factor x squared plus 4. X squared plus 4 cannot be factored. So what are we going to do in this case? Then we just disregard that. Like we just focus on the one on the top, which is -3. If you pick a number here, that would be positive. If you pick a number here, that would be negative. So when is it positive? From -3 to infinity. Parentheses and bracket. So as a note, we know if it's x squared minus 4, we can factor it as x minus 2, x plus 2. But x squared plus 4 is not x minus 2 times x plus 2. If you multiply the right hand side, you will see it's only the first one, not the second one. Next, completing the square. How do we do completing the square? Because in calculus we come across some expressions where completing the square is needed. So how do we do completing the square? First, let's look at this example. If we are given this expression, the way to do it is we make sure that the number in the front is 1. If it's not 1, we must factor it out first among the first two terms. If it's 1, we can go ahead and say the 12x, the 12, we need to divide that by 2, which is 6, and then square it. So the procedure here is you always divide the coefficient of x by 2, and whatever you get, you square that, you get 36. So then you add 36 and subtract. So that's the trick. You always add and subtract and bring that one down. So then this is what can be doing here? I'm going to complete the square, write this as something square. So the x squared goes x, the middle sign is negative, and 6 minus 35. That's completing the square. We may look at a different example. Let's say y squared plus 14y minus 11. What do we get here? Well, the number in the front is 1. So then what we have to do is take this number here, the 14, divided by 2, you get 7. Square it, you get 49. So what I'm going to do is we are going to add 49 and subtract 49 and minus 11. These go as y plus 7 square minus 60. That's the answer. We can look at another example by changing the middle term to a negative or an odd term. Y squared plus 9y plus 21. We keep this the same. 9y, we're going to take the 9 divided by 2. We just get 9 over 2. And then we square it. It's 81 over 4. So plus 81 over 4 and minus 81 over 4. And bring that plus 21 down. So this is y plus 9 over 2 all square. This is over 1 multiplied by 4 by 4. So let's see what we're going to get here. Plus 4 is the common denominator. We have negative 81 plus 84. That would give us y plus 9 over 2 square plus 3 over 4. Plus 3 over 4. How about if we are given another one, but the number in the front is not 1? So let's say we are given 2x squared minus 18x plus 11. So how are we going to complete the square? Again, if the number in the front is not 1, the first thing we need to do is rewrite this by factoring the first 2 terms. Factor the 2 out, that number, just the number. And that would give me something like this, plus 11. Now I'm going to work inside the bracket and let's see what we have. X squared minus 9x. 9, we did it earlier, so if you divide 9 or negative 9, it doesn't matter because you're going to square it then. And then you square it, you get 81 over 4. So you're going to put plus 81 over 4 and minus 81 over 4. Then we're going to complete the square on this. So how do you complete the square? X minus 9, so it's minus here, 9 over 2 square minus 81 over 4 plus 11. So then what? 2 times, well, the next step is to distribute the 2. 2 times all of this, squaring, minus 2 times 81 over 4 plus 11. So let's keep this the same. And by 2, 1 by 2, 2. So it's 81 over 2 plus 11. So what we can do here, we need to find a common denominator, which is 2. So you multiply 2 for both of them. Keep this the same. Plus, let's say 2. There's a negative 81 plus 22, as you can see. And what does that give us? 2 times x minus 9 over 2 all square. Combine these two, that gives us negative 59 over 2. Next, long division. Long division. How do we divide? If you remember long division, x cubed, let's take this example, divided by, let's say, x plus 2. Long division, it's a long process, but it's doable. So this is the long division. So you do x cubed plus 3x squared plus x plus 11 goes in here. That's called the dividend. And then x plus 2, the divisor. What goes on the top times x gives me x cubed is x squared. And now we're going to distribute this to this and to the 2. So x cubed, x squared times 2 is 2x squared. There's a minus, switch the signs, cancel. X squared, bring the x down and the 11 down. Plus x, multiply that, x squared plus 2x. Switch the signs, cancels out, negative x plus 11. Minus 1, negative x minus 2. Switch the signs, and 13. What we got in the bottom is called the remainder, and on the top is the quotient. This is the quotient. So when we write the final answers, we write that x cubed plus 3x squared plus x plus 11. When we divided by x plus 2, it gave me a quotient that is x squared plus x minus 1, plus always the remainder over the divisor, x plus 2. Next one, as another example, let's say we are asked to divide 2x cubed minus x squared plus 7x plus 14. Divide that by x squared plus 1. This divided by x squared plus 1. So what goes on the top? To get the first one, I need a 2 and I need an x. Distribute this by this is 2x cubed. 2x by 1 is 2x, so write it down below the x part. We always switch the signs and add, or you can subtract. So these cancel, bring that down. Negative x squared plus 5x plus 14. Then minus 1, multiply minus x squared minus 1. Switch the signs. These cancel out. That gives me 5x plus 15. We can't go further because the degree of the divisor is more than this. So you can't multiply or find something more than that. So the remainder here is 5x plus 15. Notice the remainder doesn't have to be always a number. It could be an algebraic expression like the one I just showed you. So that's the algebra part in this review session I wanted to cover. Now I want to move on to trig and cover the important trig parts. So trigonometry. First thing I want to talk about is how you convert, let's say, degrees into radians. So the way to convert, you take that 30 and multiply always by pi over 180. So that gives us pi over 6 radians. Say the backwards, 3 pi over 2 radians. How do you convert that to degrees? Well, to do so, this is 3 pi over 2 times 180 over pi. You always multiply by 180 over pi. These cancels by 2, 1 by 290. So that gives us 3 times 9, 90 is 270 degrees. So 3 pi over 2 radians is 270 degrees. That's the conversion between degrees and radians. Also the unit circle, if you remember the unit circle. This point, this is 0 degrees, 90 degrees, 180 degrees, 270 degrees, and it goes back to 0 as a 360 degrees. In radians, this is pi over 2 radians. This is pi, 3 pi over 2. And here we have 2 pi. 2 pi. Any point we pick on the unit circle has always coordinates cosine. So let's say it's like this, alpha. Cosine alpha, sine alpha. So this point here is 0, 1 has coordinates. This has negative 1, 0, the coordinates. So then you can say sine 90, for example. Sine 90 is the y value, which is 1. Cosine 90 is the x value, which is 0. So for 180, for example, sine 180 is the y value, which is 0. And the cosine is negative 1. That's the x value. Okay, so what about if I want to find sine 3 pi over 2? Well, you look at where's 3 pi over 2 is all the way in the bottom here. Sine is the y value, 0, negative 1. So the y is negative 1. How about other ones? Let's say sine 30 degrees or sine 45. How are we going to find these? Sine 60, cosine 30, let's say, tangent 60, or let's say cosine 60, then tangent 60. You need to know how to do all this by hand. So this reminds us of the 30, 60, 90 triangle, the special right triangles. We can put this on the unit circle, or call this alpha here, or let's call it 30 degrees, 60 degrees. If the side facing 30 is x, the one facing 90 always double, and the one facing 60 is always the one facing 30 root 3. So if I want to find sine by SOHCAHTOA, sine is the opposite over the hypotenuse, so it's 1/2. Well, I can use the same one to find cosine 30. Cosine is the adjacent, which is this one, adjacent over the hypotenuse. The x cancels out, root 3 over 2. We can do sine 60. Sine is the opposite to that, opposite over the hypotenuse, 2x. These cancel, so square root of 3 over 2. And cosine 60 is the adjacent over the hypotenuse. So the adjacent to 60 is x. The hypotenuse 2x, so that gives me 1/2. If I want to find tangent, if you remember, it's sine over cosine. That's one way to do it. And sine 60 is square root of 3 over 2. Cosine 60 is 1/2. So these cancel, so you get this tangent. Or you can do opposite over adjacent. Opposite, or it's the opposite by SOHCAHTOA over the adjacent. Opposite to 60 is x root 3, and the adjacent is x, so that's why you get square root of 3. Now how about the 45? The 45, there's another special right triangle, the 45, 45, 90 degrees triangle. If this is x, this is x root 2. Sine is the opposite over the hypotenuse. So that's 1 over square root of 2, or if you rationalize, square root of 2 over 2. Just in case if you see it somewhere in the back of the book, that's what it is. How about if they give us large angles? Say I want to find sine 330 degrees by hand. To do that, again, you can draw that on the unit circle. 330 would be here, this angle 330. Always we need to find the coordinates of that point, so we drop a height. Because the whole thing is 360, this is 30 degrees, this is 60. Because it's a unit circle, you can assume the radius is 1. That's what the radius 1. So the side facing 90 is 1, so the one facing 30 is half of it. And the one facing 60, which is this one, is the one facing 30 root 3. So what are the coordinates of the point? So you moved from the origin to the right side, root 3 over 2, and down 1/2. So what's sine that angle? Sine is the y coordinate, which is -1/2. That's how you find sine, or the 6 trigonometric functions for any angle that we can do by hand. Not like 22.7 or something like that. It has to be something we are able to do by hand. Otherwise, you need a calculator for that. Next one, I want to review inverse functions, inverse trig. So if someone asks you, what is sine inverse of 1/2? What they're asking us to do here? They're asking us, what is the angle? Its sine is 1/2. So they give you the answer. They want you to find the angle backwards of what we just did. So what would that be? What's the angle its sine is 1/2? If you go back to the unit circle, or the one we just did, that was 30-degree angle, which is the same as pi over 6 radians. And look at another one. Maybe find cosine inverse of root 2 over 2. Which angle has its cosine this? Well, that's the 45-degree that we just found, or pi over 4 radians. Very important to know those things. Keep in mind, we need it at some point, is to find the range. Keep in mind the range for sine inverse of x is always brackets -pi over 2 to pi over 2. That's fourth quadrant and first quadrant. The range for cosine inverse of x is 0 to pi. Range for tan inverse of x is negative pi over 2 to pi over 2. Very important to know. And how does that help us? Well, let's say we are asked to find sine inverse of negative root 3 over 2. How do you find that out? Well, what's the angle? It's sine is only rad 3 over 2. Only radical 3 over 2. That's how I do it. I think about it. Okay, we'll drop the negative. 60 degrees is the angle. So 60 degrees here. Remember, sine inverse can only work from negative pi over 2 to pi over 2. So you can only be from this point, from this to this. Keep in mind, this is always the positive direction. That's the negative direction. So, but since the angle is negative, so it's going to be here. It's negative 60 degrees. So the answer is negative 60 degrees. Or you can say negative pi over 3 radians. We may draw graphs. How do we do graphs? Review the graphs of both algebra and trig. Y equals x squared. Those are called the parent functions. So the parent function for this one, it goes up this way. The next one, it goes up this way. Y equals x cubed. Y equals square root of x. It goes up this way. Good to know their domain and range. How about the cubic root of x? It goes down this way. Next one, y equals 1 over x. The graph goes this way. And now I want to graph sine and cosine. Y equals sine x. X and y like that. So it's 0 and then up to 2 pi. Let's say there's a pi here, pi over 2 and 3 pi over 2. This is the range we're going to graph it. This is 1, negative 1. Here, 0, here, negative 0. So it's going to go up, down, up. And then it goes on and on, continues on both sides. Same thing on this side. We do the same for cosine. So cosine starts not exactly at 0, 0, but I start at 0, 1. So y equals cosine x. Zero, 1. And again, it's over 2 pi. It goes 0, negative 1, 0, and 1. That's the graph, and then it continues from there on, following the same pattern. Those are the graphs for the parent functions. You might need them at some point. So now another good thing, important thing here is how to solve trigonometric equations. So how to solve trig equations. If, let's say we have sine alpha equals sine beta, then the formula to help you solve these equations, alpha equals beta plus 2k pi, or 360 pi, or alpha equals pi minus beta plus 2k pi, k integer. That tells us solutions for sine, they fall in the first quadrant, let's say beta, and the second quadrant, pi minus beta, always. And we may look at an example now. Let's say we are asked to solve 2 sine x minus 1 equals to 0. To do so, we can add 1 to both sides, divide by 2, and now ask what is the smallest positive angle its sine is 1/2. We found it earlier was 30 degrees or pi over 6 radians. And now it looks like sine alpha equals sine beta. So we can move on and then solve it. X equals pi over 6 using the formula plus 2k pi. X equals pi minus pi over 6 plus 2k pi. This can be simplified as x equals pi over 6 plus 2k pi, stays the same. But the second one, you combine these, 5 pi over 6 plus 2k pi. K is an integer. Now, if they say, let's say they specify just from 0 to 2 pi, 0 to 2 pi, then you need to take values for k. We're starting with k equals 0. That gives us pi over 6. And if you substitute in the second equation, that gives 5 pi over 6. Now, if I take k equals 1, that will exceed 2 pi. If I take negative 1, that would be below 0. So it's only 2 solutions over that specific interval. Same thing works for cosine. So if cosine alpha equals cosine beta, then we have alpha equals beta plus 2k pi, or alpha is negative beta plus 2k pi, k integer. So how do you solve that out? Let's say I want to solve 2 cosine x minus square root of 2 equals 0. Always we isolate the cosine, get cosine by itself. Notice there's no condition on x, so the angle is x that we're looking for. So add square root of 2 both sides, divide by 2 on both sides. What's the angle? Its cosine is square root of 2 over 2. Is cosine pi over 4. Then, using the formula, it says alpha equals beta plus 2k pi, or x equals negative alpha plus 2k pi, k integer. That's actually the journey to calculus part 2. We will move later on to part 3, but this is what this part 2 is for.